So as you can see, we were able to add the initial velocity of the ball as it reached the top of the window to our list of known variables. Now, since we have the initial velocity of the point right here as the stone reaches the top of the window, we can manipulate that to be the final velocity of the stone for this section of the fall, for the top section. So the initial velocity of the stone as it reached the top of the window for right here would be the same as the final velocity of the stone as it reached the top of the window for right here. So since we do have the final velocity, we should figure out the initial velocity, which is the velocity of the stone at the top of the building. That would be a velocity of 0 since it is not in movement yet. So now we have the acceleration, which is still negative 9.8 meters per second squared, since this is a free fall problem and it would always be the acceleration of gravity. And we do have the initial velocity, which would be 9.229 meters per second, and we have the final velocity, and then we do have the initial velocity, which would be 0 meters per second. So we could plug that into our acceleration formula as we are searching for time. So what we can do is, so it would be acceleration equals the final velocity minus initial velocity all over time. So it would be negative 9.8 meters per second squared equals 9.229 meters per second minus 0 meters per second all over time. So that would come out to be meters per second squared equal to 9.229 meters per second all over time. So the units that we can cancel out right now are the meters, and we could cancel out this second, but we can only cancel out one of the second square since there would be two of them right there. So we can only cancel out one since we only have one other second. So that would leave us with just seconds. So we could set this over 1, and we could cross multiply or use the bow tie method. Either way works to find t. I'll just use the bow tie method. So we would multiply 9.229 times 1 divided by negative 9.8 to solve for t. So t would then be 0.9417 seconds. So we just found the time it would take for the ball to get from the top of the building to the top of the window. And that is 0.9417 seconds.